Okay, we are starting 2.2 today, and we are learning how to take derivative without using the definition of derivative. So 2.2, just basic differentiation rules. We're going to go through a lot of differentiation rules the first semester. So this is just really basic stuff. Rule number 1, the derivative of any constant is always 0, obviously. So constant is a flat line, a flat y equals something line. The slope is always 0. So the derivative of a constant is always 0. So for example, okay, so yeah. Basically, if there is no variable x, no variable means it's constant, then it's just going to be 0. So for example, if f of x is equal to 20, then the derivative is just 0. So anytime you see a constant, it's always 0. Rule number 2, power rule. Okay, so if you have a positive integer as n, and you're trying to take the derivative of that monomial, what you can do is you can bring the power down as a coefficient and then subtract the power by 1. For example, if f of x is equal to x to the 6, the derivative is take that 6, put it in the front, and then subtract the exponent by 1. So 6 minus 1, which is 6x to the 5th. If you go back and look at your warm-up, that is how you do the first 3, pretty much. Okay, take the power, put it in the front, take the power minus 1. Easy. Write it down if you have a question. Okay, now let's look at this example. This example, x is not in the numerator. However, you can change it. So 5 over x cubed, how do you change it so that they're all in the numerator? Peter? Hold on. Yes, x to the negative 3. All right, so now what you're going to do when you take the derivative is same idea. You take the power, put it in the front. Now, it's always going to multiply by whatever was already in there as a coefficient. So the derivative is going to be 5 times negative 3. So that is negative 15. X to the what? Remember, you subtract 1. Yes?
Negative 4.
Yes, negative 4. And the reason I ask is that a lot of people will tend to go the other way. They would just think negative 2 because they're thinking 1 less. So 1 less number. But remember, you're subtracting 1. Okay, go. If it's negative, it gets more negative. Hold on.
I just want to see.
Oh, I'm sorry. Yes. Okay, so take the power, put it in the front, take the original exponent, and then minus 1. The next rule is kind of the combination of the two rules. It's very similar. If you take 3x to the 4th and you are taking derivative, so this is the constant multiple, meaning like you have a constant in front of a monomial. You take the power, put it in the front, multiply together, and subtract the power by 1. So everybody, what will this become?
12x to the 3rd.
Yes, 12x to the 3rd. Yes. Okay, sum and difference rule. So sum and difference rule just means that if you are adding or subtracting two functions together, you just take the derivative of each term by itself. So there's really nothing special. Derivative, derivative, derivative of each term. So for example, if you have 5x plus x cubed, what you're going to do is take the derivative of each one by itself. So what is the derivative of 5x? Huh? Everybody? What is the derivative of just 5x? Yes, 5. Okay, what is the derivative of x cubed? 3x squared. 3x squared. Take the power, put it in the front, take the power, subtract 1. Okay, if you think of 5x, you're doing the same thing. You take the power and then take that power and subtract by 1. That is 5x to the 0. X to the 0 is 1. That's how you get 5. All right, so that is the sum and difference rule. Let's try this one. Let's have you guys try this one. dp dt, meaning t is my variable. Okay, dp dt. You have an answer, Taya? What's your answer?
3t squared plus 12t minus
Minus what?
5 over 3.
Yes. And then we don't care about that 16. That's a constant, so the derivative of that is 0. All right. We have learned 4 rules. We are able to do some things in much quicker than before. So let's go ahead and look at a typical problem. So, okay. Do the following curves have any horizontal tangent? Horizontal tangent. If so, where? What does this mean? And I need to show you how to use the calculator. Anyways, okay, so horizontal tangent. Horizontal means flat line, right? Tangent means you only go to the curve one point. So horizontal tangent lines this way, what is the slope?
0.
Very good. So how do you figure out where this curve has horizontal tangent? Yes, where the slope is 0. How do you figure out the slope is when the slope is 0? Find the derivative. Perfect. So we need to find the derivative first. Go ahead and find the derivative of this one. All right. So the derivative, someone raise their hand if yes.
Is it 4x cubed minus 4x?
Yes. Okay, so again, just review before we solve this. Horizontal tangent means when the derivative is 0. So this comes up tons. This is, you got to remember this. Horizontal tangent is what they're always going to ask. That's when the derivative is 0. Okay, now the question is where? Where is it equal to 0? So now that you took the derivative, you need to make it equal to 0 because they're asking you where. Where means x. So now you need to solve. Kind of remember your algebra skills. Solve for x. Where is x that will make this equation 0? Okay, so you can do this. Solve for x. There are obviously 3 numbers. Okay, what x values? Someone raise your hand. What x values someone I haven't called on all day today? Sky?
Is it 0, 1, negative?
Yes, 0, 1, negative 1. All right, let's have you guys try another one. This one, you do need to use a calculator. Obviously, you cannot solve this algebraically. Again, the question is where is the horizontal tangent? Horizontal tangent. If you just graph this function and if you're looking for horizontal tangent, you're looking at where all the dips are. That's very hard to find. So you do need to take the derivative. Okay, so take the derivative. Make it equal to 0. And you're checking the roots with your calculator. If you know how to do it, go ahead and finish it. If you don't know how to do it, take the derivative and then I'm going to show you how to do it. All right, someone raise their hand and tell me the derivative. Yes.
The derivative is 0.8 x cubed minus 2.1 x squared minus 4 plus 5.
Ooh, 4.
4x.
Yeah. Plus 5. Okay, so what you're going to do now is plug that into your calculator. What you're looking for is when x is going to make this 0, meaning where are all your roots? Let me graphing it. See. Remember, you should see 3, right? Because this is a third degree, you should see 3 roots. This one's a nice graph. Easy graph to see. So this looks like that. That means there are 3 roots here. If you don't remember how to find roots, what you're going to do is go to second, trace. Okay, on top of trace says calc. And then from there, you're going to use 0. So basically, you're finding the zeros. It's going to ask you for left bound and right bound. Left bound, right bound. So you're going to go like the left of it, enter, right of it, enter, and then it's going to ask you to guess. All right, questions? Yes.
So for 5x, the derivative of 5x, wouldn't it be 5?
Yeah, 5.
Can you find all of them?
Oh, never mind. I was looking.
No. Yes.
How many
Great question. How many significant figures? 3. Always 3. So something dot something something something. Always 3. Sorry, not significant figures. 3 numbers after the decimal.
Oh, okay.
Wait, there's 5?
Oh, no, only 3. Only 3. Oh, Daniel was asking for how many decimal places.
You don't know the graph.
I'm sorry. That's oh.
So
That's like how your graph would look like on a graphing calculator. It's gonna give you arrows.
Oh, okay.
Okay, go ahead and find those roots. You should have 3. The roots are negative 1.862, 0.948, and 3.539. You have to have 3 decimal places or more. If you have less, it's wrong. Okay, so even if you're really close, if you round wrong, it's still wrong. So please be careful. All right, the next thing we're going to do is just tons of derivative practice with all kinds of situations, so you're very familiar with all the skills. All right, let's do one at a time. Go ahead and do this one. Okay, raise your hand if you have the answer. Johnson. Sorry, say that again.
2x to the power 5.
Uh-huh.
2x to the 3.
2x to the 3. Okay. You guys are pretty much advanced level, so let's try the harder ones. Number 4. Whenever you see some kind of square roots or some kind of roots, it's much easier if you turn it into a fraction. It's easier to have a number there than a symbol. Okay? So change it to a fraction exponent. All right. Okay, Eleanor, tell us what you did first before you take the derivative.
Oh, so I changed the square root to 1/2.
Okay, so it's x to the 1/2. Good. All right, so what is your derivative?
I said it's 1/3 and then x to the negative 1/2.
Yes, very good. Please make sure you subtract 1 whole integer. This is a common mistake. Okay, Zach. No, it's fine. So you can have square roots in the denominator, and it's fine. Yeah, you can do this if you want. That's it. You don't have to simplify anything, pretty much. Okay, let's try another one. This one's too easy. Number 6. When you have something like this, there are 2 variables pretty much. Combine it into 1. You want to make it easier before you start taking derivative. All right, Jana, you want to tell us the answer? But tell us what you did first.
Okay, so answer first will be t times t to the power 1/2.
Okay, t times t to the power 1/2.
And it would be like t squared times 1/2, so it would be 2 times 1/2, right? No? 2 times.
Yes, 3/2. Yeah, so 1 plus 1/2, so 3/2. Okay, now v prime. Someone raise your hand if you have an answer. Elizabeth.
Oh, no, wait.
William.
3/2.
Huh?
3/2 t square root t.
Yeah.
Or 2
So bring that 3/2 forward and then subtract 1 whole number, okay? Okay, next. Okay, let's try this one. This is a common mistake, so please be careful. Please be careful. Change it to a fractional exponent first. All right, George, tell us what you did first.
So I changed it into 2x to the negative 1/4.
Okay, now you take derivative. What do you get?
We'll do that, and then I get negative 1/2 x to the negative 5/4.
Yes, very good. Negative 5/4. All right, please be careful.